My advanced engineering class was given a rocket car project. They had to design a rocket car, do all the calculations including thrust, acceleration, and speed, and then verify the calculations with actual rocket car races.
Alright, so this is going to be one of the fenders of our rocket cars. It's going to go in the back, and there's going to be two of them, right? So I have this pattern I just traced on here. I'm going to cut it so it's roughly this shape, and then I'm going to sand the edges so it's pretty smooth. And we're going to do two of those, so they're the wheels right here, and then this is the body cone, and then the nose cone's going to be up here.
Okay, so I used the laser cutter to make a lot of the parts of my rocket car, including the vertical fin. So what I did was I drew it out in AutoCAD, sent it to the laser cutter, changed the settings to suit the piece of wood that I needed, and here it is, all cut out.
This is the nose cone that I made in Autodesk Inventor, which is a professional CAD software. I made it to be streamlined and help with stability of the car, and I made it to the exact dimensions necessary so I could easily 3D print it and use it for the product, and if necessary, reproduce it accurately. I did this to cut out the human error that I knew I would have with my lack of woodworking experience, and I tried to bring it into a field that I was more comfortable with.
So this is the in-progress nose cone. I need to sand it down a little bit more so it's still a circle so it fits inside the rest of the body too. As for the rear wheel wells, so this is the end result. Here are the wheel wells. This is the nose cone. It's also got the wheels on the bottom. These are steering eyelets. We threaded a string through this tube and then in between the wheels through these hooks so that it would stay on course. I also painted it pink because I think it looks great.
We used Google Spreadsheets to determine how long it would take our rocket cars to cross the finish line. We had to account for a number of variables, but most importantly, we accounted for the coefficient of rolling friction, which we determined by inclinating our rocket cars until they eventually started moving and finding the tan of that angle. For the surface area, we used Inventor's profile selector from the front-facing view to find that cross-section. For the normal force, we placed our vehicles inside of a wind tunnel and applied different velocities of wind to them so that they experience different normal forces. And using an extrapolation, we found at certain velocities, a certain normal force would be applied to our vehicles. Then using the Rocket Mime's nice catalog of different rocket equations, we plugged these into our spreadsheet and found that for each split second, the exact distance that the vehicle has covered, and therefore at the exact moment that the rocket car has passed the finish line.
Alright, so this is the timing system we used for the project. So essentially we created these 4 frames here, which were just made with a laser cutter and some poster board. And what happens is there are these laser pointers shining across each of the frames, and 2 cars are raced at once. They start here and end here, but these are actually 25 meters or so apart. When they first cross the laser beam on the starting frame, the timer starts, and when they cross the second beam on the second frame, the timer is stopped. And then from there we compare the times of the cars, and whichever car was faster is the winner, and these lights here indicate which one that was. This one here is sort of like the base station because it has our microcontroller. That microcontroller connects to the computer, which then is used to record the times and save it for later use. Another thing that happens is there's a button connected to this so that one person can push it, and then both the rocket engines are automatically started electronically, so we know it's a totally fair race.
My stem advance. Start from the gun.
So to start making the rear wheel,
Why do you look so mad at the camera?